Hello everyone! In this video, we're going to learn about how to find the area under a normal curve, a key concept in statistics. Our objectives are to first define what is a normal distribution and second is to solve for the area under a normal curve. By the end of this video, you'll understand what a normal distribution is and how to calculate the probabilities within it. Now, let's get started.
A normal distribution is a symmetric bell-shaped curve that describes how data is spread around a mean, average, and is also known as Gaussian distribution.
Normal distribution is the proper term for a probability bell curve. In normal distribution, the mean is 0, and the standard deviation is 1. It has a zero skew and a kurtosis of 3. Normal distributions are symmetrical, but not all symmetrical distributions are normal.
First, symmetry. The left and right side mirror each other. Second, mean, median, mode, all three are equal and set at the center. Third, spread. The standard deviation controls the width. Larger standard deviation means more spread.
The key properties of finding the area under the normal curve. First is the properties of normal distribution. The total area under the normal curve is 1 or 100%. The curve is symmetrical around means. The standard deviation determines the spread of the curve. Second is the empirical rule. 68% of data falls within one standard deviation. 95% of data falls within two standard deviation. And 99.7% of data falls within 3 standard deviation.
Using z-score, the z-score formula is z equals x minus mu divided by sigma. Mu is the mean and sigma is the standard deviation. Finding the area. Use the standard normal table to find the area of a given z-score.
Now we're going to solve to find the area of a normal curve. We'll be using z-score table and a z-score formula to completely find the area of a normal curve. Here's the z-score table on the right corner and the z-score formula that we'll be using on the next example or the second example. Now let's say in the first example, find the area under the standard normal distribution curve between 0 and negative 1.55. By simply looking in the z-score table, you'll be able to find the area of the normal curve even if the given is negative. You still can use the z-score table. Now, since it's negative 1.55, the first thing you have to look for is the 1.5, which is on the left corner of the table, and the 0.05 on the top. The intersection of the two should be the area under the normal standard distribution curve between 0 and negative 1.55, which is 0.4394, or in converting to percentage, it's 43.94%. The next example is how using the z-score formula. In this example, we'll explore how to determine the percentage of the population with IQ scores below a certain point. The given or the problem is deviation IQ scores, sometimes called the Wechsler IQ, are scores with a mean of 100 and standard deviation of 15. What percentage of general population have IQs lower than 92? So this is the formula that we'll be using. The x will be the 92, the score, the mean is 100, and the standard deviation is 15. First is you have to subtract the x and the mean, which the answer is negative 8, and divide it to 15 to the standard deviation. The answer is negative 0.53. This means our z-score is negative 0.53 and that 92 is 0.53 standard deviation below the mean. Now we consult a z-table. Look for 0.5 on the left corner and 0.03 on the top. And then the intersection of it will be 0.2019 or 20.19%. Therefore, approximately 20.19% of the general population have IQ scores lower than 92.
In short conclusions to recap, normal distributions are symmetrical and defined by mean and standard deviation. Convert values to z-scores to use standard normal tables.